Hey there, do you ever wonder why astronauts float in space? Could it be because of their weight, their mass, or maybe both? Now to find out, stay tuned, okay? Welcome to Rise Up Namibia. My name is Nata, aka the resistor of bad and the lover of good. Hashtag dark and lovely underscore walk by faith and not by sight. So, what if I asked you a second question? Is to say, why do we, as human beings on Earth, why don't we float like the astronauts in space? No matter how high we jump, it's like there's a constant force that is pulling us down. Actually, there is a force that is pulling us down, and this force is called gravity. Okay? Now, say for example, you have your bathroom scale and you want to weigh yourself. Now, when you weigh yourself, this is actually the measurement of how much force of gravity is acting up on you. Okay? Now, the reading that you get on the scale is not your weight, but this is your mass. Okay? Now, let's quickly check the units. Mass is measured in kilograms, while weight is measured in newtons. Remember, weight is a force, so it's also measured in newtons. Now, what about gravity? Gravity is measured in newtons per kilogram. Now, it is also measured in meters per second squared, but meters per second squared is mainly used when we talk about the acceleration of free fall. Okay? So I'll advise you to use newtons per kilogram when you are dealing with questions that involve mass, weight, and gravity. Okay? Do not get confused between the two units because they are basically the same thing. What you should keep in mind is mainly the number 10. Okay? Because the gravitational strength, the gravitational field strength is 10. It's 10 newtons per kilogram. Or if we are to talk about acceleration of free fall, we say 10 meters per second squared. Okay? So you need to know this 10 by heart. It is mainly also written on your NSSC question paper on the cover page in the instructions. But mostly learners don't read instructions, so they miss it. Okay? Now, there's actually a formula that combines these three. Okay? Or that is related to mass, weight, and gravity, which is W equals to mg. Now, the W stands for weight, the M stands for mass, and G stands for the gravitational field strength, which is this 10 newtons per kilogram on Earth. Okay? Not on any other planet. On any other planet, they vary, but on Earth, it's 10. Okay. Now, given this formula, let's look at this guy that is on the bathroom scale. If we are to calculate his weight, remember we found his mass, which was 55 kg. Okay? Now, what is his weight? Now, according to this formula, we can find his weight by multiplying his mass by the gravitational field strength, okay, which is 10 newtons per kilogram. So if it's 10 newtons per kilogram, we substitute his mass into the formula and the strength of the gravitational field. Now, here I'll explain to you why I recommend you use newtons per kilogram when you deal with this type of questions. Because when you use newtons per kilogram, notice that this is 55 kg. You have a kg on the side of the multiplication sign. Now, on the other side of the multiplication sign, you also have a kg. Now, when you use newtons per kilogram, you cancel out that kg and you are left with a newton. Okay? Now, that newton that you are left with will be the unit in your answer. What do I mean? Look, when you multiply 55 multiplied by 10, it gives you 550 newtons. Okay? So basically, after cancelling out this with this, you are basically left with this n, which is newtons. So that n comes in your answer. Okay? So that's your final answer. Let's quickly look into some extra examples involving weight, and mass. Now say for example, this is your study table in your room, okay? And then on your study table, you have your laptop. Now your laptop is 4 kg, okay? Now then you ask the question, what is the weight and the mass of the laptop? Now, just a reminder, weight is measured in newtons, while mass is measured in kilograms, right? Now, knowing these two information, we can conclude that the mass of the laptop is 4 kg, right? As we are given here. Now, if we conclude like that, the question is, what is the weight of the laptop? Now, to find the weight, we can simply use the formula that we saw on the previous slide, which is W equals to mg. Now, the question is, do we have the mg? What is our mg? Our mg is the mass and the gravitational field strength. Now, the m is the 4 kg that we got here. And the gravitational field strength, think about it. If this is in your room, it means it's on Earth, okay? That is why I say you should know that 10 newtons per kilogram by heart. So which means if it's on Earth, the gravitational strength will be 10 newtons per kilogram. So you substitute that into your formula, which will make it 4 kilogram multiplied by 10 newtons per kilogram. Now notice again that if you use newtons per kilogram, you will have a kilogram on the right hand side of the multiplication side. Now, because it's appearing on both sides, you cancel out this kilogram with this kilogram, and you are left with a n. And you know your answer will have n as a unit. Okay? So what is 4 multiplied by 10? It gives you 40. 40 what? 40 newtons. Why did we get newtons? Because we cancelled out the kg with another kg, we are left with a newton. Okay? Good. So let's continue. Say for example, this is your dad, and he's an astronaut. So he decides to take your laptop to Mars. Okay? Now, let's ask again the same question. So if your dad took your laptop to Mars, what will the weight and the mass of the laptop be? Now the mass will still be 4 kg, okay? While the weight we'll need to calculate. Now how do we get the weight? Remember guys, we need to use the formula to get the weight, okay? Now do we have the mass and the gravitational field strength? The mass is still 4 kg. Now the gravitational field strength is 3.7 newtons per kilogram on Mars, okay? Now don't worry about this 3.7 newtons per kilogram. They normally give it to you if they ask a similar question. They'll normally give it to you within the question. Just read the question properly, okay? Now again, it's the same method. When you multiply this kg, will cancel out this kg. Then you'll be left with this newtons. So when you multiply 4 multiplied by 3.7, it will give you 14.8 newtons because of this n that is left, okay? Now I want you to notice that on Earth, the mass was 4 kg. And then on Mars, the mass was also 4 kg. Now what about the weight? The weight on Earth was 40 newtons. But on Mars, it was 14.8 newtons. So what does this tell us? This tells us that the mass stays the same no matter where you are. It doesn't matter if you are on Earth or you are on Mars, you are on the moon, wherever, whatever planet you are, your mass never changes. But the weight is the one that changes. Why does it change? It changed because of the gravitational field strength or the gravitational acceleration, okay? So the mass stays the same, but the weight changes, okay? How do we know that? Because of this 4 kg that was on Mars is still the same 4 kg that is still, okay, the excuse me there, the same mass which was 4 kg on Earth is still the same mass which is on Mars. Okay? While if you check the weight on Earth, it's 40 newtons, but when you check the weight on Mars, it's 14.8. Okay? Now, how about when your dad is on Earth, where the gravitational strength is 10 newtons per kilogram, and then he weighs 70,000 grams? What will his weight be? So I'll give you 10 seconds to calculate his weight, or if you feel 10 seconds are too few, you can pause the video and then work it out. Okay? Okay, so his weight will be 700 newtons. Okay? How did we get the 700 newtons? First of all, one thing you need to keep in mind is that his mass should always be in kg. No matter what you're calculating, your mass must always be in kg, which is kilograms. Now, when you look at our mass here that we were given, it was in grams. Okay? So now, let's convert the 70,000 grams into kilograms. How do we do that? By dividing by 1,000. Okay? So we get 70 kilograms. Now, if we have 70 kilograms and we have our 10 newtons per kilogram, we can use the weight formula, which is this one. Okay? So we substitute our figures, which is the M being 70 kilograms and the G being 10 newtons per kilogram. Our answer will be 700 newtons. And remember, this kg cancelled with this kg. That's why we have this N, which is the same N in the answer. Okay? And that is how we got the 700 newtons. Now, how about if your dad took off and went to Mars or the moon? Let's say he went to the moon, where the gravitational field strength is 1.7 newtons per kilogram. What will his weight be? So I'll give you another 10 seconds to calculate his weight. And then if 10 seconds are too few, feel free to pause the video and then calculate. Okay, so his weight will be 119 newtons. Okay? Now, how did I get this 119 newtons? Remember, mass is a constant, or mass does not change. So, whether he is on Earth, or he is on the moon, or he is on Jupiter or Mars, or on the sun, whatever planet or wherever he is, his mass stays the same. Now, given this, that his mass does not change, we take that 70 kilograms and we use it in our formula. Except now our G has changed, because now he's no more on Earth, where the G was, like on Earth the G was 10 newtons per kilogram. But now on the moon, G, which is the gravitational field strength or gravitational acceleration, is now 1.7 newtons per kilogram. So we substitute his mass multiplied by the 1.7 newtons per kilogram. What will the answer be? It will be 119 newtons. And that's how we got this answer. Okay? Now remember again, just notice that when we use newtons per kilogram, we normally just cancel out the kgs and we are left with that N, and which is the same N that we write in our answer. Okay? Now, remember, and I'm emphasizing this more so that you don't forget it, because you can get a question about the mass. Just remember that the mass never changes. Because notice that now, when you look at this man on Earth, he weighed 70 kg. But on the moon, he also weighed 70 kg. So if you are asked about the mass and the weight, always emphasize that yes, the mass never changes. What changes is the weight. Because on Earth, his weight is 700 newtons. But then on the moon, his weight is 119 newtons. Now, this means that when this man is on Earth, okay, when he's on Earth, he feels heavier than when he's on the moon. Because when he's on Earth, his weight is 700 newtons. So if he's to jump up, the gravitational pull even pulls him faster to the Earth. But when he's on the moon and he jumps up, he'll even feel lighter because his weight is only 119. But when he jumps, he will even be slower to be pulled back down. Okay? So, this sport car is made up of 3,500 kg and has a weight force of 50,500 newtons on an unknown planet. Now the question is, what is the gravitational field strength of the unknown planet? So that is your question. Number one, just bring out your formula. Now after you bring out your formula, check what are you given in your question. Use your formula. So use the W for the weight. Are you given a weight? Yes, you are given a weight of 50,500 newtons. Are you given mass? Yes, we have a mass of 3,500 kilogram. Are you given the gravitational field strength? No. So knowing that you need to calculate the gravitational field strength, what do? Now when you look at your formula, it doesn't say gravitational field strength equals to something. It says weight equals to mass multiplied by gravitational field strength. So what you need to do, you need to make G the subject of the formula. Now, if you don't know how to make G the subject of the formula, worry not, because I will be leaving a link down below in the description. Just go check it out. It will be written how to make a certain letter subject of the formula. Okay? Now we want to make G the subject of the formula. So this is mg, which means it's multiplication in the middle of m and g. So how do we cancel out multiplication? We cancel it out by division, okay? So we divide both sides by the letter that we want to cancel out. So here we want to have g alone. So we want to cancel out m. So we divide both sides by that m, okay? Now it will cancel out this m. Now if it cancels out the other m, you'll be left with g equals to w divided by m, okay? Now let's quickly flip it around. Don't get confused. These two equations are just the same. I just put the g on the left hand side and the w over m on the right hand side, okay? Now when you look at what you are given on the right hand side, you can actually substitute it into the formula now, okay? Which is our weight on top being 50,500 newtons and our mass 3,500 kg. So you divide them and you'll get 14.4 newtons per kilogram. Again, how did I know that the unit will be 14 newtons per kilogram? Because on top I have a newton, which is 50,500 newtons. This newton, and on the below I have a kg. I'll just bring them down and then it will be that n, which is newton per kilogram. I put the per there because it's at the bottom, okay? So the per is like a division, okay? So that's your final answer. Now, how about if your brother works for NBC as a cameraman and has this side table in his room where he places his camera. Okay? Now, the question says, the camera resting on the table is 40 kg. What is the force of gravity acting on the camera? And then you are given in brackets here to say use G equals to 10 newtons per kilogram. Good. Now, let's look at our question again. What's our question asking for? It's asking for the force of gravity acting on the camera. Now, you should know that force of gravity is equal to weight. Okay? Now, once you hear that force of gravity is equal to weight, this is actually good news for us because we know the formula for weight. So we can use the formula for weight to find the force of gravity because the force of gravity is equal to weight. Okay? So if we can use the weight formula, let's quickly see what we are given. Are we given the W? No, we are not given the W. Are we given the M for mass? Yes, we have 40 kg. Are we given the G? Yes, we have 10 newtons per kilogram. So from there, we just substitute it into the formula, and then we work it out. What is 40 kilograms multiplied by 10 newtons per kilogram? The 2 kgs will cancel out, and we are left with 400 newtons. Okay? Now this over here is Melvin looking for a free partner to pass the ball. Okay? Now Melvin picks up a ball with a force of 20 newtons, 2 meters from the ground in Olympia Stadium before throwing it. Okay? Given that G equals to 10 newtons per kilogram on Earth and 1.7 newtons per kilogram on the moon, A. What is the mass of the ball in Olympia Stadium? B. What is the mass of the ball on the moon? And then we have C that says, what is the weight of the ball on the moon? Good. Now, let's start with A. That states that that asks, what is the mass of the ball in Olympia Stadium? Now, to find the mass, we can actually still use our weight formula. Okay? Now, remember to check what you are given in the formula. Are we given W? Yes, we have a weight of 20 newtons, which is in the question. Are we given M, which is the mass? No, we are not given the M. It's actually asked in the first question, which is A. It says, what is the mass of the ball in Olympia Stadium? Now, are we given G? Yes, we are given G, which is 10 newtons per kilogram. How do I know that it's 10 newtons per kilogram? Look, the question says, what is the mass of the ball in Olympia Stadium? Okay? Now, don't get confused. You already know that Olympia Stadium is in Windhoek. Where is Windhoek? Windhoek is on Earth. Okay? Now, the fact that it's on Earth, it means its gravitational field strength is 10 newtons per kilogram. Okay? Because you are given here that on Earth, it's 10 newtons per kilogram. Guys, what you really need to do is just, if you don't understand the question, you always need to reread the question. Okay? So now, knowing that you are given these figures and you need to find M, what do? You make M the subject of the formula. Okay? So how do we make M the subject of the formula? By dividing both sides by the letter that we want to cancel out. We want to cancel out G, so we divide both sides by G, which will cancel out on the right-hand side. You are left with M equals to W over G. Okay? So let's quickly flip it around. Knowing that M equals to W over G, we substitute our figures within the formula. Now, after we substitute, we'll have 20 newtons divided by 10 newtons per kilogram. Now, notice again that when you use newtons per kilogram for your gravitational field strength, because on top you have 20 newtons, that Newton will cancel out with the Newton at the bottom. Okay? Then what are you left with as a unit? You are only left with kg. Now look what will happen. When you divide 20 divided by 10, what answer do you get? You get a 2, right? So that will be 2 kg. And it makes sense because mass is measured in what? It's measured in kgs. Okay? So that's your final answer. Now what does B say? B says what is the mass of the ball on the moon? So I'll give you 10 seconds to calculate the mass of the ball on the moon. Okay? And again, if 10 seconds are too few, feel free to pause the video. Okay. So what is the answer? The answer to B is 2 kg. So someone will be wondering, what do I mean 2 kg? Remember from the previous slides, we said what? Mass is constant, or mass does not change. And that's one thing about physics, guys. Okay? It has carry-on questions, which means you need to get the first question right, which is A, and then when you get to B, you will need the answer that you get, like you got at A. Okay? So B's answer is also 2 kg. Why? Because mass does not change. Okay? Wherever you are, whether you are on Earth, whether you are on the moon, the sun, Mars, Jupiter, wherever you are, the mass does not change. Now C is asking, what is the weight of the ball on the moon? Okay? So let's quickly get rid of everything here. Good. Now, how do we find the weight? Again, let's just use the weight formula, which is W equals to mg. Now look what you are given. Do you have W? No, we don't have W. It's actually what we are looking for. We don't have the weight of the ball on the moon. Because here in our statement here, we only had the weight of the ball on Earth, which was 20 newtons. But now on the moon, we don't have the weight. Now, do we have the mass of the ball? Yes, we have the mass of the ball. Now, do you see what's happening here now? The mass is the answer we got in our first questions, like A and B. Now, we need the same mass to calculate our answer for C. Have you noticed it? So that's what physics does. It has those carry-on questions. So now M equals to 2 kg. Now, what is the weight of the ball? Now, do we have G, which is gravitational field strength? Now, on the moon, what is our gravitational field strength? It's in the statement, which is 1.7 newtons per kilogram. So we write it down. So from there, we substitute it into our equation. So what is 2 kg multiplied by 1.7 newtons per kilogram? We already know this kg will cancel out with this kg. So we are left with a newton there. And 2 multiplied by 1.7 equals to 3.4 newtons. Why is it newtons? It's the same newton that was left within our calculation. Okay? And that is your final answer. So do you still wonder why astronauts float the space? That's because in space there is no gravity, okay, to pull them down, so they float. Did you find this video helpful? If yes, please do give us a huge thumbs up and subscribe to our channel for more videos like this. And don't forget to share, okay, with friends, family and classmates. Remember, together we rise to higher heights, apart we all stay behind. Cheers.